Okay, good afternoon, class. Okay, so yesterday we have learned the concept of complex number and how to do subtraction, addition, multiplication of two complex number, all right? And especially division of two complex number. Oh, we have done all this. Okay, okay, so today we are going to do another part, which is 4.3, equality of complex number. Right, so we will see how we can use the property of equality of two complex number to solve the question. Okay, number one, let's say z is a complex number in the form x plus yi. Okay, and w is another complex number in the form u plus vi, such that z and w are the same, equality. All right, therefore I plus yi will be equals to u plus vi. Alright, so from here, when we compare the real part to real part, so x will equals to u. And when we compare the imaginary part, y will equal to v. See? Alright, so thus two complex numbers are equal if and only if the real parts and the imaginary parts are separately equal. Alright, and next will be, so a complex number equation is therefore equivalent to two separate equations. Two separate equations means what we have discussed just now. The real part x equals u and the imaginary part y equals v. Okay, so let's see one example how we can use this property. Alright, so example 4.3a. Alright, so let's look at here. We only look at example 4.3a. Alright, so the question says find the values of x and y in each of the following equation. Alright, so 1a I want you to do as homework. Alright, because this one very simple. You just expand the right hand side, then you compare the real part and imaginary part. So I will discuss b. Alright, so how to find x, y? So this is the question. Let's say this is, after we simplify, this one will be another complex number. Let's say this is equal to x plus yi. So remember what we have done yesterday. When we want to divide two complex number, we multiply with the conjugate. Okay, so denominator, when multiply one conjugate pairs, so we just square the number. Alright, so this one expand as usual. Okay, so 2i, 5i, minus 5. Why? Because I square, right? I square is negative 1, remember? So negative 5. Alright, so we simplify it. And you see that it is equals. Okay, so after we simplify it, alright, after we simplify it, then it becomes, so 2 minus 5 is negative 3, so negative 3 over 2. Alright, so this is 7i, so plus 7 over 2i. Alright, because of the equality, right, so you can compare the real part to the real part. So x equals negative 3 over 2 and y equals 7 over 2. Alright? Okay, so question 1a you do as homework, and I want you to do question 2 as quiz after this lesson. Alright? And then you forward your solution to the Google Drive. Alright, so very simple. You see right hand side is a square, so you expand the square, and then you rearrange it in the form of a plus bi. Alright, then you compare the real part and the imaginary part like this. Alright, so to find the real values of x and y. Okay, so means x and y, they only want the real value. 6 marks. Okay, the second property is a complex number equation is equivalent to two separate equations. Like this one, real part and imaginary part. Alright, so this property provides an alternative method for division by a complex number. Okay, so remember yesterday when we learned how to divide two complex number, we use the method like this, multiply conjugate, right? So now we are trying to use another method, which is the equality of two complex number to solve this. Alright, so let's look at this example. So 3 plus 4i over 2 plus 3i equals to a plus bi. Alright, So now we don't use this method, multiply conjugate. So we use the equality, the property of the equality of two complex number. So first step, we move this one to the right hand side. All right. Then we expand. Okay, 2a, 3ai, 2bi, minus 3b. Well, because I square is negative 1. Then we rearrange it, real part to real part. So 2a minus 3b. Alright, then imaginary part 3a plus 2b, then I will factorize out. Okay, now we compare the real part. So this is real part, this is also real part. So 2a minus 3b equals 3, equation 1. Then we compare the imaginary part, 3a plus 2b equals 4, equation 2. Alright, then you see. Then we solve lah. So from equation 1, we rearrange a as subject. Then we sub this one into equation 2, become like this. Alright, then we solve this equation and we find that b is equals to negative 1 over 13. Then sub in here, you calculate, then you get a equals 18 over 13. Okay, so you get your a and b. Therefore, 3 plus 4i divide 2 plus 3i is equals to this answer. Alright, so to do the division of two complex number, we have two methods. One, use the method multiplied with the conjugate, and second, use the property of the equality of two complex number. Alright? So this is how we can use the property. Alright, next. Number 3. So the method of equating real and imaginary parts of a complex number also provide one way of determining the square root of a complex number. Okay, remember this concept, very important. The square root of a complex number is another complex number. So let's say I have one complex number, x plus yi. So the square root of this complex number will be another complex number. Okay, remember this concept. Alright, so let's see some example. So number 1, I'm going to discuss 1a. So 1b you do as homework lah. Alright, so the question wants us to find the square root of each of the following complex number. So 1a, so will be like this. Alright, so we are asking to find the square root of 15 plus 8i. Alright, so we say let square root 15 plus 8i is another complex number. Alright, so remember a and b should be real number lah. So next step, we square both sides so that the square root will eliminate. Then this one you expand the square, the quadratic. So first term square, second term square. B square, I square. I square again is negative 1. Then 2 times ABI. Then now you compare. When we compare the real parts, so this is real parts. A square minus B square is real parts and this is a real part. Okay, then we compare the imaginary part. This is imaginary part, so this is imaginary part. Alright, so next you choose either A or B as your subject will be the same. Alright, so for me I choose A. So A will be equal, so 2 shift here, simplified become 4, then B shift here. Alright, so A is equals to 4 over B. So I sub this one into the first equation. A is 4 over B. So expand it, 16 over b squared. So to solve this equation, we don't want denominator. We always want to eliminate the denominator. So we multiply the whole equation by b squared. So when this one multiplied b squared simplified left, 16. This one multiplied b squared, this one multiplied b squared. Alright? Then we arrange it in a proper way because I don't want negative, right? So I shift the b4 here. So positive b4. Positive 15b squared, and this one also shift here, right? So minus 16. Okay, and this one is something that we can factorize like this. So you get b squared equals 1 or b squared equals negative 16. Remember, just now we say a and b must be real number. And this one, give me b is the imaginary number. So we reject it. Since b must be real number, so we reject this answer. So here only. So b squared equals 1, your b will be equals plus minus 1. Don't write a equals plus minus 4. Please show separately. So when b equals positive 1, sub in here, your a equals 4. So when b equals negative 1, sub in, you get a equals negative 4. So you have two sets of answers. Means you have two square root. Therefore, the square root of 15 plus 8i will be either 4 plus 1i, or square root of 15 plus 8i will be negative 4 minus I. Two answers. So normally, square root of a complex number will have two answers. Means after I square this one and this one, I will get the same answer. Alright? But one very important thing, remember, we are calculating the square root of a complex number, and we normally will get two answers. But these two answers are not conjugate. They are not conjugate. You see, even though the sign of the center opposite plus minus, but this one not the same. See, this is 4, this is negative 4. They are not the same. So it's not conjugate. Please don't confuse. Alright? They are not conjugate. Okay. So B you do as homework. Then I want you to complete 2 as quiz also. STPM 2005. Do this as your quiz. So this one and this one. Look at this. The complex number Z1 and Z2 satisfy this equation. Alright, so you're asking to express Z1 and Z2 in the form A plus BI, where A and B are real numbers. So this one is Z squared equals this. So what is Z? If Z squared equals 2 minus 2 square root 3i, then Z is square root 2 minus 2 square root 3i. Right? So means that we are going to calculate the square root of this. So let square root of this equals A plus BI. Then you continue the step like this. So you will get two answers, right? You will get two answers. So one will be your Z1, one will be your Z2. So actually we are doing the same thing. We are doing the same thing, just that they ask in different form. Don't confuse by the question. Alright? Okay. So another homework will be checkpoint 4.2. Please complete question 1 to question 4. It will be related question like this. Is it okay? It's supposed no problem, Alright, we will go through one more part, which is 4.4. Okay, complex root of a polynomial equation. Also, still remember to find the roots of polynomial. Alright, so in chapter 1 you have learned, right, how to find the roots for quadratic equation, cubic equation, quadratic equation, and so on. Alright, but in chapter 1, okay, you are only find the real roots. Okay, but now we are going to find the complex roots. Alright, so let's start with the quadratic. So let's say you are given a quadratic equation in the general form ax squared plus bx plus c equals 0 with real coefficient. Real coefficient means all these a, b, c are real number. So if b squared minus 4ac, still remember this determinant. So b squared minus 4ac is equals to negative. It's a negative number. Then the roots of the equation will always have conjugate pairs of complex number. Means that if b squared minus 4ac is negative, means this quadratic equation has no real roots. So if no real roots means it has complex roots. When it has complex root, it must come in conjugate pairs. Alright, so look at this example. So let's say you are given a quadratic equation and the determinant is negative. Then we can find the roots by using the quadratic formula, which is negative b plus minus b squared minus 4ac over 2a. Alright, because just now we say that b squared minus 4ac is negative. So I multiply negative 1 here. Alright, so we separate into two terms. So negative b over 2a plus minus square root b squared minus 4ac over 2a and I, because negative 1, square root negative 1 is I. Alright, so this is too complicated. So let's say we represent this part as p and this part as q. Therefore, this quadratic equation will have the complex roots, which are p plus qi and p minus qi, which is conjugate pairs. So you see p and p same, q and q same, only the sign at the center different. Then only we call it conjugate pairs. Alright, so this is quadratic. Alright, then next is for cubic. Still remember cubic? So cubic equations, I hope you still remember the roots. It has three types of roots for cubic. Okay, one, if the curve of the cubic intercept x-axis at 3 different points. 3 different points like this. Then we say this cubic equation has 3 real roots. Alright, so if the curve, the cubic curve, cut the x-axis like this, 1 and 2 here, this one touch. So we say that this cubic equation has 2 real roots, and actually it's not 2 because cubic is degree 3, it must have 3. Because when this one touch, remember we have repeated root. Repeated roots, x minus a squared. So this one considered 2 roots lah, but they are the same law. And number 3 is this one. Alright, and if the cubic curve cut the x-axis like this, only intersect 1 point. So this one will give a pair of complex roots. Alright, so you see, if the graph of a cubic polynomial intersect the x-axis at only 1 point, then the equation fx equals 0 will has 1 real root, which is this one, and 2 complex roots, this one. Alright, and this complex, as long as it has complex root, it definitely occur in conjugate pairs. Alright? So number 4. So generally, a polynomial equation with real coefficient of degree n more than 3. Just now is quadratic, cubic. How about if more than 3? It means power 4, power 5. Okay? It will behave in the following manner. Alright? A. Its complex root always occur in conjugate pairs. It always occur in conjugate pairs. And B. If n is odd. Alright, if n is odd, so the polynomial equation will have at least 1 real root, like this. Okay, at least 1. And then other will be complex root. Because when n is odd, the curve will be something like this, and the two ends will be go to negative infinity and positive infinity. So means that it's something like decreasing or increasing function. So it definitely will cut the x-axis at least 1 point. That's why at least 1 real root. Alright, so if n is even, means power 4, 6, 8. Alright, so the polynomial equation may not has any real roots. Alright, so because like this, or let's say this is quadratic w. So you see the whole curve is above x-axis, never intersect with x-axis. So it has no real roots, or like this. Okay, it has no real roots. So all will be complex root. So if this is quadratic, then it has 2 pairs of conjugate roots. 2 pairs of two conjugate pairs of complex root. Alright. Okay, so this is generally about complex root of a polynomial function. Okay, I will discuss 4 examples. So the rest will be your homework. Okay. So first question, example 4.4, we explain easier one. So find the roots of this quadratic equation. All right. So look here, very simple. All right. So when you check your b square minus 4ac, so b square is 4 minus 4 times a times c, so 8. 4 minus 8, negative 4. So you know that it has complex roots. So when it has complex roots, definitely we cannot factorize them. Alright, so we are going to use the quadratic formula. Negative b plus minus b square minus 4ac 2a. So sub in all your ABC. Sub in all your ABC. And you found that this is square root negative 4. Alright, so square root 4 is 2. So square root negative 1 is I. And then after that we can simplify all the 2. Alright, therefore your complex roots will be negative 1 plus I, or negative 1 minus I. So you see, if it is complex roots, it come in conjugate pair. You see, the real part is negative 1, same. Okay, I, same. Only the sign at the center, opposite, plus, minus. Then we only call this conjugate. Alright, so remember, only complex root in conjugate pairs. Don't confuse with just now that one. Remember this? The square root of a complex number will have 2 different answers, but they are not conjugate. I really hope that you don't confuse these two concepts. Alright, so this is very simple. Okay, next. Question 2, you do it yourself lah. Same like this one, just that they use Z only. Okay, question 3. Find the roots of the cubic equation. X cubed minus 1 equals 0. Cubic equation. Still remember cubic equation in chapter 1? Remember I asked you to memorize how to factorize it. Okay, so x cubed minus 1, after factorize it is x minus 1, x squared plus x plus 1. Remember it or not? If it is x cubed plus 1, then it's x plus 1, then here is minus. Remember it? So what's to memorize? Okay, so after factorize means x minus 1 equals 0, or this quadratic equals 0. So x equals 1. So you see, it has one real root. Alright, and this part, when you check b squared minus 4ac, you know that it is negative, so complex root. So use quadratic formula, submit all your ABC. Then after you simplify, you get this thing. Alright, then we split it into 2. One is negative half plus square root 3 over 2i. Negative is I lah. Alright, then next one is negative half minus square root 3 over 2i. So you see, it comes in conjugate pairs. Negative half same. Square root 3 over 2, square root 3 over 2 same. Only this sign opposite. Then it's conjugate pairs. Alright? Okay, question 4, solve quadratic. This one you try yourself, just like this. X power 4 minus 1, you know that can factorize as x squared plus 1 and x squared minus 1. So this one you give you 2 real roots, and this one give you 2 complex roots. Okay, you try this one, right? Okay, next. Number 5. Okay, now just now we find the roots of the equation. Now they give you the other way around. Form the equation whose roots are 1 minus 3i and 1 plus 3i. Right? So this question they give you the roots and they want you to form the equation. You see, these are the conjugate pair. 1 minus 3i, 1 plus 3i. Okay? So still remember your SOR, POR, sum of product, a sum of roots and product of roots. We are going to use this. Okay? So the question give you 2 roots. So x lah. Right? Then we find the sum of roots. Add them. 1, add these 2. So 1 plus 1, 2. 3i minus 3i, no more. So you see your SOR definitely is a real number. POR also the same. Okay, POR. So this is conjugate pairs, right? When you multiply conjugate pairs, remember, just square the 2 number, add it. So you get 10. Alright, then sub into the formula. Still remember this formula? X squared minus SOR x plus POR. So just put in. Sub in the XOR and POR. So this is a quadratic equations with these 2 complex roots. Alright? It does not seem like what you have learned in chapter 1. Just that now replaced with complex roots only. Alright? Next. Question 6 also I want you to do as homework. You see, they ask you to find the complex root of this equation. This one as usual, you find the complex roots. Alright, so if these roots are alpha and beta, confirm the relation. Alpha plus beta means SOR equals to negative b over a, and product of roots equals to c over a. This one also, again, you have learned in chapter 1. You refer back. Okay, refer back and you settle this. Okay, what else? Question 7. Okay, without calculating ABC, they don't want to know what is ABC. Evaluate negative b over a and c over a if one of the root of this equation is this one. If they give you one of the root is a complex root, negative 12 plus 3i. So what is second root? If complex root must come in conjugate pairs, right? Therefore, you know the other root will be negative 12 minus 3i. So since you already have 2 roots, can you find these 2? Can, right? Negative b over a is actually SOR, sum of product. And c over a is actually product of roots, a sum of roots and product of roots. Alright? So means that after you have get the roots, you will do something like question 5 that I have shown just now. Alright? And question 8. one root of the equation. So you are given one quadratic equation and they tell you this is one of the root. Again, complex root. So can you find another root? Can, right? Conjugate pairs. Then you're asking to find the values of P and Q. Okay, so this one is just like question 5 that I have discussed just now. Oh, something like this. See? Since you have two roots, you find SOR, find POR, then you form your new quadratic equation. Then you compare. You know what is your P and Q. Or if you don't want to do this, then after you calculate your SOR, POR, you equal this one. Or from here, you get your B and A, C and A. Then from here, straight away, you get your PQ already. Alright? No problem, right? It's quite easy lah. Since you have learned this one in chapter 1, function. Alright? So it just that now change to complex number. Alright, so I'm going to discuss question 9. Okay, so question 9 is STPM 2012. Alright, so you see that it's a 16 marks question. It's a long question. So remember in the first page, right? From here we see that this chapter never come out in part B yet. So it will come out anytime, okay? Because it can be a question that given you more, given you 15 marks. If really come out, then it's lucky lah, because normally it's not difficult. Okay? So STPM 2012. So you are given that z square. Z square is 2i over 1 plus 3i and square. A. Find the real and imaginary part of z square. Z square first. Means you have to elaborate z square into a plus bi form. So we can see the real and imaginary part. Then hence obtain z1 and z2, which satisfy the above equation. Remember just now I have one quiz that asks you to do this one. Okay, also find z1 and z2, right? Yes. Okay, so after I discuss question 9, so you should able to do this. Alright? Alright, okay, so see, this part give you 10 marks already, which is really not difficult. Okay, let's see. So this is z square. Okay, z square. So they want to see the real part. So first step, don't immediately multiply the conjugate. You must expand the square first. So first term square, 3i square. So i square is nearly 1, right? So minus 9. Then 2 times this one, so plus 6i. Alright, so simplify it. I see 8 and 6, right? So I factorize out 2. Become minus 4 plus 3i. So 2 and 2 can be simplified. Now only you multiply the conjugate. To realizing the denominator, right? So multiply conjugate pairs, so you just square the two numbers. So I multiply with this one, you get this. Alright, so this is 25. So this z square, after simplify, it become, so the real part is 3. So 3 over 25 minus 4 over 25 I. Right? So your z square after simplify in a plus bi form is like this. Therefore, the question asks you to find the real and imaginary part, right? So don't stop here. You have to answer this. So the real part of z square is this one, and the imaginary part of z square is this one. Alright? So you complete half. Okay, next. Hence, obtain z1 and z2. Means find z. You are given z square. So to find z means, you are given z square. So z will be square root of the right hand side. Correct? So let's say z is the square root of this. Means we are going to find the square root of a complex number. And we know that the square root of a complex number is another complex number. Alright? So we let square root of this equals to p plus qi. I don't use a plus b because later also got a, b here. I don't want you to confuse. Right? And we know that p and q both must be real number, right? Okay, so next step, like what we have done just now, we square both sides to eliminate the square root. And this one, just now we already know that after simplify, it becomes like this, right? So expand this one. So p square minus q square. Minus is because I square is negative 1. Then 2 multiplied pqi. Okay, again, you compare the real part. So p square minus q square will be equals to 3 over 25. Then you compare the imaginary part. 2pq is equals negative 4 over 25. Alright, so after simplify, and I choose p as subject, so p is equals negative 2 over 25q. Okay, sub this one into this equation like this. Alright, so expand it, you get this. So to continue, we eliminate the denominator. So the whole equation multiplied by 625q squared. So when this one multiplied, simplify, left 4. This one multiply this, you get this. So this one multiply this. 25 and 625 simplify is 25. 25 times 3, 75. Alright, so rearrange in a nicer way. So this one shift here, plus this one also shift here. Right? And we found that it is something that we can factorize like this. Alright, so this part, 25q squared plus 4. So since q must be real number, and this one will give us complex imaginary number. Also, we reject this answer, so only left this. So q squared equals 1 over 25. Therefore, q equals plus minus 1 over 5. Alright. Okay, so I shift it here first. Then we continue. Yeah. Alright. Q plus minus 1 over 5. So we calculate separately. So when Q is positive 1 over 5, sub in here. Sub in here. So I get P equals negative 2 over 5. And when Q equals negative 1 over 5, P is equals 2 over 5. So two set of answers. Okay, means that you have two Z. So Z1 will be this one. So I choose this one as my Z1. And this one as my Z2. So again, please remember, this is square root. So square root, no, not conjugate. Don't confuse. Alright, so 10 marks. From here, come here, 10 marks. Alright? Okay, next step. B. So given that Z1 and Z3 are the roots for this quadratic equation, where a and b are integers. Alright, so find the values of a and b. And determine Z3 and deduce the relationship between Z1 and Z3. This question a little bit funny. Because part 1, we already need to know what is Z3 already. I don't know why they ask again. But doesn't matter. Since the question like this, we just continue. Alright, so you are given Z1 and Z3 are the roots. Alright, so for this quadratic equation, Z1 is a root. So from here, I get this is my Z1. So means that this question, part B, it depends which one you choose as your Z1. You can choose this one as Z1, this one Z2, doesn't matter. You use what you choose as Z1. Alright, so just now I choose this one is Z1. So the root is Z1. So do you know what is another root? No problem, right? This is quadratic. And we know that complex root must come in conjugate pairs. So if I know Z1, then definitely I know what is Z3 also. It's a conjugate. 9 minus plus. So you check, Z3 and Z2 not the same, you see. This is negative 2 over 5. This is 2 over 5. That's why I say just now, this is not conjugate pairs. But roots, yes, they are in conjugate pairs. Alright? Okay, so Z1, Z3. This one done. Alright, so we to calculate A and B, I use SOR, sum of root. Okay, I add the two roots. And we know that SOR is equals to negative B over A. Negative B over A. Alright, so you just solve lah. This one and this one cancel. So add 4 over 5. So you get A is equals to negative 4. Correct? Integer just now they say A and B are integers. Okay, then I use POR, product of roots. I multiply them. Alright, and it equals to C over A. C over A. Alright? So multiply conjugate pair, we just square the two numbers. Alright? So you get this, then you calculate, you get B equals 1. 3 marks. Alright? Then next, determine Z3. So Z3 I already have lah. So just copy again lah, since they asked, right? And deduce the relationship between Z1 and Z3. So definitely they are conjugate pairs. Alright? It's not difficult, right? It's actually quite simple. It's actually quite simple. Alright? Okay, so I will stop here. So other than that, please complete checkpoint 4.2, question 5 to question 14 also. We will relate it to all this. Use the concept of equality. Find the roots for quadratic, cubic, and so on. Do more exercise lah. Alright, so I will stop here. Okay, so please remember, after this, finish the 3 quizzes. 3 questions that I ask you to do as quiz, remember? Okay. One, two. Where is another one? Just now I asked you to do this one as quiz, this one as quiz. Two only. Two only. Okay lah. Two only. Yeah, 2 only. It's okay. Alright, so finish the 2 quizzes and upload to the folder that I give it to you. Alright, and please try to complete all the homework. Alright, so tomorrow I will send you another video regarding Argand diagram and modulus and argument. Alright, thank you class.